Right. So now that we've learned all the logic gates, okay, all the different logic gates that we wanted to learn, we're going to learn a new topic called Boolean expression. Boolean expressions, okay. Does anyone remember what is a Boolean expression? Yes.
So basically, the type of logic that a logical statement, which you get like true or false or 1 or 0.
That's right. Okay. So a logical statement that results in a Boolean value either be true or false, or 1 or 0. Okay. So you're writing expressions very similar to what we've done with the logic gates. We use symbols to write logic gates. Okay. But this time we're going to start writing expressions to express those symbols. Okay. So let's have a quick revision on logic gates. Okay. Let's see how much you remember. Okay. So the first one. Can anyone remember this one? Yes. Not gate. Okay. That's a not gate. Next one. OR gate. Yes, that's OR gate. Okay. Let's see the next one. AND gate. Yes, AND gate. This one's an AND gate. Right. What about the next one? Next one. Let's see. This one. XOR gate. That's it. Yes, that's XOR gate. So we kind of have an idea in terms of if I give you a symbol, you know from that symbol what gate this is. Okay. So we can also represent each symbol that I've just shown you using something called a truth table. Everyone remember the truth table? Yes. Of course we remember the truth table. So if you have a logic gate, for example, NOT gate, we can have a truth table for NOT gate, and the truth table looks like this. So this is a truth table for NOT gate. If I were to take this symbol away, if you simply look at the truth table, you will automatically able to recognize that's actually a NOT gate. We could do the same thing for other gates as well, like the OR gate. The truth table for OR gate looks like this. Okay, so again, if I were to take away the symbol for the OR gate, you can still be able to recognize just from the truth table this is an OR gate. Also AND gate, the truth table for AND gate is this. So again, if you didn't see the symbol, if you just saw the truth table, you'd be able to tell this is an AND gate. XOR gate, again the truth table for XOR gate. Okay, if you look at it, you know instantly, you will know straight away there's a difference between OR gate and XOR gate. Just by looking at the truth table, you will be able to distinguish between OR gate, AND gate, okay, and NOT gate, and so on. So the truth table is another way of representing, okay, our logic gates. So NOT gate, okay, using symbol, we have the symbol here. We have the truth table. Also, we can recognize. We can express it in using a symbol. We can express it using the truth table. We can also write it using expressions. So in this case, we have an input A going into NOT gate. It's going into NOT gate. So I can just simply write the word NOT. So we can also represent that using NOT gate, not A. A is going in as an input and going through the NOT gate, okay, and producing result. We could do the same with the OR gate, okay. But with the OR gate, how many inputs do we have? 2. We have 2. So we have to have both inputs. So the first input we look at is input A, and we also have an input B, okay. Input A and input B going through which gate? OR gate. So we can just simply write the word OR in between to indicate A and B going through OR gate. Okay, we can just write a simple expression like that. AND gate, okay, I also have 2 input. We have input A, input B, and it's going through. We just simply write the word AND. So input A and input B going through AND gate. Next one, XOR gate. We also have 2 input. We have input A input B, and it's going through XOR gate. You just simply write the word XOR gate. There are symbols for each Boolean operator. So instead of writing the word AND, OR, XOR, you can use symbols to represent each one. Okay, so we're going to have a look at the symbols now. So the first one, NOT gate, we wrote not A. We actually wrote the word not. You can simply replace that, input A, and write a line on top of it to indicate not A. This red line represent not gate. So A, input A, is going through the logic gate not gate. Okay, so this A and the line on top represents not. Next one, we have OR gate. So in this case, A and B going in through OR gate. So we need to replace the word OR. Okay, so the way to do is A, input B, and you replace the word OR with the symbol plus sign. Plus sign, yeah. So this plus sign represents OR. Okay, so input A and input B going through OR gate. Next one, AND gate. Again, we have two input. We have input A and input B. What do you think the symbol for AND is? Can anyone remember? Okay, a simple dot. Okay, that indicates the AND gate. Input A and input B going through AND gate. Okay, next one. That's an interesting one. Okay, XOR. So how many inputs do we have? Two input. Yes, we have input A and we have input B. Can anyone remember the symbol for this one? Yeah. Okay, so it's a plus sign with this circle around it for XOR gate. Yes. So you can just simply replace the word XOR with a plus sign with a circle around it that represents XOR gate. Okay. Operations and symbols. Okay, that's what it looks like in full. So you have operations not A with a line on top. A and B going through AND gate. You go A dot B. The dot represents AND gate. A or B, A and B going through OR gate, and the OR gate represents with a plus sign. And then you have A XOR B, A and B going through XOR gate, that represents a plus sign with a circle around it. Is that clear? Yes. Okay, you put your hand up. Okay, right. So we can easily do this exercise now. Okay, so let's do a little exercise. Rewrite the Boolean expression using the Boolean expression operator. So first one, what would it look like? A and B. A dot B. A dot B. Right. Question B. A or B and C. What do we need to do first? Yes. Brackets first. Why? Anyone know why? Okay, you say BIDMAS, BODMAS, whatever it is. According to the law, okay, that we have to do the brackets first. Okay, we have to do the brackets first. So inside the bracket, what's inside the bracket? A or B. So what would that be replaced by? A plus in the middle, B, and then and C. Dot C. Okay, so let's see if you're right. A plus B dot C. Next one. This is an interesting one. A, we have to do the brackets first, remember. So we go through, that's why I'm reading the brackets first. A and B. A and B going through AND gate. What would that be replaced by? A dot B. And that would be the brackets part done. Okay. And then what will happen? What happens to the word not? Okay, yes. you do a line over A or B or what? The whole expression, because you can see this whole section is going through the NOT gate. So yes, okay, A dot B not, okay, A dot B not, okay. Last one, okay, we have to do the brackets first. So the first part is the bracket pass. What do you have to do? Yes. Okay, so you got A, X or B. A and B going through the XOR gate. So what symbol would we be in between A and B? Plus with the circle around it. And then you've got the next one is OR gate. What would that be? Plus, and the input C will come in. So it will look something like this. Okay, is that clear? Any question? No. Is everyone clear? Okay, so that's one way of expressing. We looked at the symbol, we looked at these expressions. We can write, using those operators. We can also do symbols. Okay, so we can create very first one. Let's start drawing the diagram. Let's see what it looks like. The first one. Okay, the first one. Okay, so number one, A, question A and B. That's a very simple one, yeah. Okay, so A and B, just simple one. A and B going through AND gate. So it looks like this. Okay, do the next one. B, we have to do the brackets first. So we have to draw A or B. Okay, A and B going through OR gate. So let's draw that first. A and B going through OR gate. So we got that. What happens next? What do we have to draw next? Okay, so the result of A and B going through OR gate, the result of it going through AND gate, okay, the result of that going through AND gate, and there's something else is coming in, another input. Input C is coming in. Okay, so the input C is coming in. Okay, next one. Question C. What do we do first? Yes. Brackets first. Okay, we do brackets first. What's inside the bracket? A and B going through which gate? AND gate. So that's what we need to do first. We need to show A and B going through AND gate. We've done the brackets part. Okay, so what do we do next? What happens next? Yes. Yes, because the NOT gate comes in now. You have to NOT all that. Okay, so the NOT gate comes in, and that's question C is complete. Okay, next one. Question D. Okay, what part do we do first?
You do the brackets first.
Okay, we do the brackets first. What's inside the bracket?
So A and B is going through XOR.
Okay, A and B, input A, input B going through XOR gate. We need to draw that first. So let's draw A and B going through XOR gate. Here's your XOR gate. Now the bracket part is done. What do you do next? Yes.
You add the OR gate at the end.
Exactly. So you need to put this plus sign represents OR gate. So we put an OR gate. Okay. So this means the input A and input B going through XOR gate, and the result of that going through OR gate, and also there's the input C coming in. Okay, input C coming in, and that's your final diagram. Okay, is that clear? Yes. Any question? Anyone not sure or want to ask any question? Any question? No.